Okay, so our lesson today is on solving what I'm going to call bad quadratics. So the easiest way to solve any quadratic, and let's remember what solving means. To solve means to find. The roots, zeros, solutions, or x-intercepts. That's what it's going to mean to solve. The easiest way to do that, if we can, is to factor. And that's what we've been working on, the little puzzle that you set up and you pick the two numbers. But that's not always possible. For instance, like it's possible for us to set up problems, for instance, like an 8 on the top and a 5 on the bottom, that don't have two numbers to pick. So we've got to have some other way to solve those. And our way, we're going to talk about that here in just a minute. Before we talk about that, you need to know that every quadratic must equal 0 before we can solve it. That's why I set up all those factoring problems equal to 0 the other day, so that you could see that ahead of time. So there's a formula that we're going to use. It's called the quadratic formula, so you should write that down. And it looks complicated, I'm not going to lie to you. It looks like a beast of a formula, but to be honest, it's really easy. And what's so cool about this is people are going to watch you doing this and think, oh my gosh, it looks like you're doing really, really difficult things, when really you're doing, like, it's actually not going to be that bad. So you're going to feel like you look super intelligent. And with this, you get to hear me sing a lovely little song. If you were here in class, you would get to physically watch it with your own eyeballs, but instead you'll just have to listen. So the tune of this song is dun 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 dun, right? It's Pop Goes the Weasel. All right, so the song that we're going to be singing is to the tune of Pop Goes the Weasel. And it gives us this formula. So I'm going to show you the formula and then explain what everything means. All right, so the formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so let's talk about what are some things that you might notice in there. And if you look at that for a minute, I hope some things stand out to you. For instance, I hope that you recognize this negative b over 2a, right? That should remind you of the axis of symmetry. That's where that formula comes from, negative b over 2a. The other thing that might be a little bit weird for you is this plus or minus, right? That is red, plus or minus. It's going to give us two different answers, and we'll talk about that here in a little bit. And the idea is that if you think about the axis of symmetry, right, our axis of symmetry line is going to run straight down the middle of wherever the parabola is, and the roots end up being on equal sides of that axis of symmetry. So it's plus so much and minus so much. That's why we have to do plus or minus, so that we can get the correct root. And then the A, B, and C come from, it's the same place these A and B came from before. The A comes from the number in the front, so that's like the A x squared. The B comes from the number in the middle, plus bx. And the C, which is new to you now, just comes from this number at the very end that's by itself. All right, so what I think you should have written down in your notes should look like this. I just like for you to point out for yourself that what the axis of symmetry is and what the plus or minus does. So let's look at some example problems. Okay, so here's the first one. Notice that this does equal 0 to begin with, so that's good. My tip to you when we start any of these is to say or label what A, B, and C are at the very beginning. So I'm going to write that out. A equals 2, B is going to equal negative 3 in this case, and C is going to equal 4. I do have people that say, well, can I not just put A, B, and C above the problem? There are going to be times when that doesn't work, and I'm also nervous for you about signs. So for right now, I'm going to ask that you actually write them out. So now I'm just going to set up my formula. X equals, and in my mind, I sing this every time, even now, even 15 years after I first took algebra. All right, X equals negative B, and since B is already negative, I'm going to put positive 3, plus or minus square root. I know that square root symbol's got to be really, really big. B squared. Now, B squared, you need to do that in your head. Don't trust your calculator, because you know your calculator lies to you sometimes. So go ahead and just do that part on your own. Negative 3 squared is just 9. That's negative 3 times negative 3. B squared minus 4AC. So I pulled the 2 for A and the 4 for C. all over 2a. And notice that all over, I didn't talk about this on the other slide, but notice that this fraction bar runs the entire length of the formula. It's not just under the square root symbol, it's under the entire thing. That's why we say all over 2a. And the only other part that I want you to get right now is if you think about order of operations, we talked about this in class today when we were reviewing, order of operations, we have to do parentheses first, and that includes parentheses, absolute value, big fraction bars, and really long square roots, right? All those grouping symbols. So we need to do the square root part first. So what I'm going to have you do first is to use your calculator to just do this part underneath the square root. Not even the square root symbol, just the part underneath. So we're going to simplify this to be 3 plus or minus. If we type that in, we should get, I'm pretty sure that's negative 23, all over 2 times 2, which is 4. And this is where we're going to just leave a space. We're going to come back to that here in just a minute. Okay, here is where I would like for you to try 2 on your own. Try to set them up. If you need to go back and rewatch the other part, how I did the other one, do that. But pause the video before you check the answers, because if you can't set these up, you're going to be really in trouble for the next step that we're going to do. Seriously, pause the video and try these problems. Okay, now that you've tried them, let's check and see what we got. So I didn't even label my A, B, and C because I'm doing this from my memory. So I set this up. -4, right, you can read that. Notice that I went ahead and did the squared part, the 16 on my own instead of writing 4 squared down. And then I'm going to work out that part underneath the square root. And I got -4 plus or minus the square root of 0 equals 8. And that's where we're going to kind of put a pin in that problem for just a minute and come back to. All right, question 3. X equals, all right, you can check that. And then I got 6 plus or minus the square root of 12 over 4. All right, so that's all for that first part of the lesson. Okay, so here's back to our first example that we did today. I want to bring some kind of things full circle, so I might blow your mind for a minute, sorry. We kind of left a pin in this, and you know, we said that we need to figure out square roots first in order of operations. So we already simplified it, and we get this negative square root of 23. Well, we talked about breaking that down. 23 doesn't break down. And if you go to type in the square root of negative 23 in your calculator, it's going to say error. And that is because you cannot take the square root of negative numbers. Your calculator will actually say error, non-real answer. So this means that our answer is not real. Okay? That means that since x-intercepts or roots, that is where the parabola is going to cross the x-axis. If it's not real, that means it is never going to cross the x-axis. It will never cross. So that means that this function, whatever it looks like, I still know that it has an axis of symmetry right here of 3/4. So if my graph is counting by 1s, 2s, I know my axis of symmetry is like somewhere around here, but the parabola is somehow going to open in a way that it doesn't actually touch the x-axis. It's like it's going to be above the x-axis and never hit on the x-axis anywhere. So this is an example of, we said non-real solutions. So what you would write is x equals 2 non-real solutions. And you're going to learn more in algebra what that, like algebra 2, kind of what that does, or actually how to find those non-real solutions. But I just need you to know if you have negative on the inside, it never crosses, and it's non-real. You can put 3 n's there. Negative, never crosses, non-real. All those go together. Okay, let's look at these last, this next case, and that's where we have square root of 0. Now, square root of 0, we actually know the answer to. It's kind of a trick question. What times itself equals 0? 0. All right, so we're going to break that down and make that be -4 plus or minus 0 over 8. Now, remember the plus or minus gives us two answers. So I actually want to break this apart to find my two answers. So I'm going to read this in two different ways. The first way is if that's a plus sign. So I'm going to write -4, x equals -4 plus 0 over 8. And the other answer is -4 minus 0 over 8. Now, there will be times that you get to this problem and you can't really work much else out, but if these are easy numbers that you know how to work with, then work it out. For instance, I know what -4 plus 0 is. It's -4 divided by 8, so this is -4 divided by 8. If I simplify that one more time, I'm going to get that x equals -1/2. All right, now I'm going to work my other one out. X equals -4 minus 0 is -4 divided by 8. Okay, and hopefully you see you're getting the same answer twice. Okay, now we're getting this same answer twice. I hope that it might be ringing some bells, I don't know. This is called same answer twice. This is called a double root. We talked about this the other day. And double roots touch and turn. Okay, so remember, and they're also, not only do they touch and turn, but you all told me yesterday that double roots, that's where the vertex was. So if we say that, all right, we're going to hit here at -1/2. My parabola is going to hit at -1/2, touch and turn. So this is going to be the only root. It's also the vertex, which we just said. And if you think about, right, we said plus or minus. This has to do with how far away from the axis of symmetry you're moving. If you think about that, that makes a lot of sense. I mean, if the vertex is and the roots are on the axis of symmetry, obviously you're not moving to the left or to the right any to find those roots. Okay, so this is an example of a double root. Let's look at the last one. All right, so I'm going to start the same place that I did on the previous example. Now this 12, we learned today how to break that down. All right, square root of 12, if I'm looking for perfect squares, those are 4 and 3. And the square root of 4 is perfect. It's 2 square root 3. So I'm going to rewrite this as 6 plus or minus 2 square root 3 over 4. And then I can simplify that. Now this is a little bit tricky. We can simplify that using these whole numbers right here. So if anything can divide into all three, it has to go into all three whole numbers, we can do that. All of these divide by 2. So this is equivalent to saying x equals 3 plus or minus 1 square root 3. So I'm just going to write square root of 3 over 2. And if I want to split that into my two different answers, that is 3 plus the square root of 3 over 2 and 3 minus the square root of 3 over 2. All right, for the sake of your notes, these are exact answers. So if you're ever asked for an exact answer, this is what they're looking for. And if I type this in my calculator, my approximate answers are going to be 2.3, and I'll round that, 2.4 and 0.6. And so this is an example of two real roots, because when I graph this parabola, I don't even have to know a ton about it, but I just know that it's going to cross in two specific places, one at this 0.6 number and one at 2.4. So it's going to cross through the x-axis at two different places. That's why we call it two real roots. All right, so we're going to work on those things tomorrow, get you a lot of good practice so that you feel really, really good about these in case any of them come up on your state test. And for moving forward, you're going to see this a little bit probably in geometry and definitely in algebra 2.